Hello, Year 7, and welcome to Sound Lesson 5, which is Week 3 of Lesson 3. Today, we're going to look at our last sound lesson called Echoes and Ultrasound. So the things we need to know by the end of a lesson is what an echo is, how echoes can be used to calculate distance from an object using the formula distance equals speed multiplied by time. We're going to learn about what some examples of echolocation are. We're going to learn about what an ultrasound is, and then hopefully we're going to learn some uses for ultrasound as well. So why not dive straight in with what an echo is? So an echo. Yes, all right, I stopped being annoying. I do apologize. But an echo, they're reflections of sound waves. So sound wave is a vibration, so it's energy traveling. And because it's energy traveling, that energy can rebound, okay, or reflect. Just like light can, sound waves can reflect as well. So it's just a reflected sound wave. So if I was there and I yelled and then I heard an echo of my own voice, it is my sound wave, my yell, bouncing off that building and coming back towards me. And then I'm able to hear it. So we can use echoes to work out how long it takes to work out how far an object is away. So we can time how long it takes for our echo to come back and reach us in order to work out the distance the object is away from us. And we can use the formula we used last week to calculate the distance. So distance equals speed multiplied by time. So at the end of this video, you can watch us actually use an echo. So the way you use it and the way you calculate distance is you use the formula distance equals speed times time. So you make a short, sharp sound like a clap, or with the video we actually use a drum, and then we time how long it takes us to hear that second noise, that returning echo. So if I yelled echo, echo, I time how long it is from when I said it to when I actually hear that echo bouncing back. And we know the speed of sound in air because the speed of sound in air is 340 meters per second. We learned that in a previous lesson. So we can use what we already know, which is the speed of sound in air of 340 meters per second, to work out the distance away. So we use the formula distance equals speed times time to calculate how far away the building is. But then we divide our answer by 2. Why? Why are we dividing our answer by 2? Look at the diagram below. Can you think of it now? Hopefully you can, and you realize that, hey, look, the wave's got to get there and back. So it's just telling us the whole distance the wave travels, not the fact that it's traveling there and back. So we need to divide that by 2, because the distance from that object is only half the distance that the wave is actually traveling. We don't want to know how far the wave travels. We want to know how far the object is from us. So my question is, a practice question, this person yells at that building and then hears the echo 2 seconds later. How far away is that building? What I want you to do is stop this video and have a go at the formula. So distance equals speed divided by time. And then remember, you need to divide it by 2 and work out how far away the building is. Stop the video, have a go at that question. Dun, dun, dun. The building is 340 meters away. Why? Because distance equals speed times time. So they then multiply our speed, which is 340 meters, because she's standing in the air. And then it takes 2 seconds, so our time is 2, which equals 680 meters. But that's the total distance the wave has traveled. So we need to divide that by 2 in order to get the distance from the building, which is 340 meters. So, what ways or what uses echoes? Dolphins, for example, use a form of echoes called echolocation. So if you want to have a look, this is a brilliant video. So download the PowerPoint that's attached to the Show My Homework and open the slide and follow the link on this slide to the video of the dolphin using echolocation. It's brilliant. It's incredibly interesting. So what's happening is dolphins send out a sound wave, but then they're able to register that echo and use the echo to work out how far something is away. Just like we worked out how far that building was away from us about 30 seconds ago, the dolphin uses the same thing, but it's using it in water. So it's not going to be 340 meters per second as the speed. It's going to be something different because it's water and waves travel faster in a liquid because the particles are closer together. So that is how a dolphin uses echolocation. The sound bounces off the fish back to the dolphin and is able to work out where it is, how big it is, and things like that. So ultrasounds, you might have heard of ultrasounds. If you've hurt yourself badly enough, you might have even had one. Your mother, it might be a good idea asking your mother what an ultrasound is because she probably, or she would have had one when she was having you as a child. She might even have the videos or some pictures of her ultrasound of you. And you might even be able to see yourself in an ultrasound before you were born, which is kind of incredible to think about. But basically, if you remember, our hearing range is about 20,000 hertz or 20 megahertz, sorry. And frequencies above 20,000 hertz are called ultrasounds. So we can't hear an ultrasound, but animals can hear ultrasounds. So dogs and bats, for example, can hear ultrasounds. In fact, bats use ultrasounds when they're flying so they don't collide with objects in the night, which is another thing you could watch online, which is incredibly interesting. But basically, ultrasounds are waves. They're still sound waves. They're just super high frequencies, so we can't hear them. And they reflect better. And so they're also more directional than a regular sound. So my voice is not that directional. So if I go, hello, and then it goes, hello, back. I don't know where that echo's come from. It could have come from any wall or roof around me. But a ultrasound is much more direct. It gives direction so that animals such as dogs and bats understand where that sound is reflecting off, which gives them a much better picture of the things around them. So ultrasounds are just reflected waves that they then can catch and understand. So hearing range of the animal kingdom is really interesting. Bats can hear up to 100,000 hertz, which is why their ultrasound use is so incredible. Cats up to about 50,000, dogs up to about 40,000, dolphins also up to about 110,000, grasshoppers not very much so, only 100 to 1,000 hertz. Humans, we're anywhere from about, 20 hertz all the way up to about 20,000 hertz. So we've got a reasonable range, but nowhere near the range of a bat. So we're pretty good, but not that great. So as I said, bats use echolocation. So what they do is they send out an ultrasound pulse, and then it bounces off their prey back to them, and then they know exactly where their prey is. And it also helps them navigate so they don't fly into things in the night, which is incredible. Well worth going to watch a video on bats using ultrasound. They're incredible, incredible creatures. So as I said, that we use ultrasound in order to see fetuses inside mothers. Your mum's probably seen an ultrasound before. And then they're displayed on the screens. They're really useful at seeing things like that. They're also used by ships trying to look for submarines. So sonar, or sound navigation and ranging, is what it stands for, is used by ships to detect submarines and find submarines. So it was incredibly useful in World War II for finding things. So there's some of the other uses for ultrasounds in human world rather than just in the animal kingdom. So make sure you watch the video at the end on what a reflected sound looks like. Make sure you complete the worksheet attached to the Show My Homework work. Make sure you're completing the SAM learning tasks that I have set you on SAM Learning. And also make sure you're completing the Show My Homework quiz that I've also set you on Show My Homework. So there is lots and lots of work for you to be doing. Make sure you are submitting everything, every one of the worksheets you do. Make sure you're throwing it online and submitting it. Click submit on that Show My Homework and put it in so that we know you are participating in the lessons. Hope you've had fun. Next lesson is really exciting. We are moving on to space, which is incredible. I'm very excited. It involves a bit of research for you guys, having a look at some things, and then a few lessons as well. So remember, well, firstly, keep watching this video to watch the experiment, but remember, always stay safe, take care of each other, and keep on learning.